Now let us understand about a few more characteristics of a normal distribution. This is by far the most important probability distribution. Normal distribution is characterized by a bell curve. Yeah, that means it has a bell-shaped curve in that way. And the properties are mean is equal to median is equal to mode of a normal distribution. And it is symmetrical across the central tendency. So on the left and the right side, you would find 50% of the data. And it has these properties. You'll have to focus on these properties rather than knowing on how these values are calculated. Yeah. I've given you all an example of International Cricket Council cricket ball circumference, ICC cricket ball circumference. And we all know that the upper specification limit is 229 mm and the lower specification limit is 224 mm. If a specific process operates at plus minus 1 sigma, one standard deviation, plus minus 1 standard deviation, and this is your mean, right, peak. Now, if a process operates at plus minus 1 standard deviation, that means roughly 68% of the cricket balls which are being manufactured meet your specification limits. That means if I'm manufacturing 100 cricket balls, out of that 68 cricket balls would meet your specification limits or the circumference. Rest of the cricket balls, rest of the 32% cricket balls, or 32 cricket balls, those cricket ball circumference would either be less than 224 mm or greater than 229 mm. It will fall here. In this way. These are all your defective cricket balls which are not meeting the customer requirements. If the process operates at plus minus 2 standard deviation, your specification limits would be here. 229 mm, 224 mm. Out of 100 cricket balls that are manufactured, roughly 95% of cricket balls would meet the specification limits. That means out of 100 cricket balls that are manufactured, 95 cricket balls would meet your customer requirements. Another 5% of the cricket balls circumference would fall within this range. Here, within this range. So these are not meeting your specification limits. If I say that a specific process is operating at plus minus 3 sigma rather, that means your specification limits would be here. You would have your 229 mm here and 224 mm here. If a process operates at plus minus 3 sigma, that means 99.73% of the cricket balls would meet your specification limits. That means out of 100 cricket balls that are manufactured, roughly 99.73% or 99.73 would meet your specification limits. Rest of the 0.27, those many cricket ball circumference would fall beyond your specification limits. Those are defectives. Those will not be considered. On similar lines, you know that 6 sigma is a process improvement methodology, right? So if you can fit in plus minus 6 standard deviations between your lower specification limit and upper specification limit, then this process is said to be operating at plus minus 6 sigma, sorry. And this is called as 3.4 defects per million opportunities. That means if you're manufacturing a million shirts, there would be only 3.4 defectives in that sense. Right? If you're manufacturing a million mobile phones, and if each mobile phone is an opportunity, then there would be not more than 3.4 defects out of a million mobile phones which are manufactured. However, in real world, each mobile phone would have a lot of components. One mobile phone might have a lot of components such as screen, motherboard, your battery, so on and so forth. Each component is called as an opportunity. In that way, if you have a million opportunities, if you operate at 6 sigma, there would be only 3.4 defects per million opportunities here. I'm just giving you some additional insights here. Now, if you fit in plus minus 3 standard deviations on either side of the mean, it is not 6 sigma. From this mean, which is your peak, to one side of the specification limit, there has to be 6 standard deviations that you fit in. One more thing here is, though you feel that 3 sigma is all about 99.73% defects and 6 sigma is all about 99.999% defects. Though from percentage terms, there is minuscule difference. If an electricity firm operates at 3 sigma, you would not have power for 7 hours every month. But if the same firm implements 6 sigma process and tries to improve the process, and if it achieves 6 sigma standards, then you would not have electricity for 1 hour every 34 years. You can do a Google search. You'll get to know all of these things. All right. Now, let me explain about a few more characteristics before we move on to the next topic. A random variable can be represented as following a normal distribution approximately with mean mu and standard deviation sigma in this fashion. So you can characterize each and every random variable with mean mu and standard deviation sigma. Now let me explain that using this example, post which I will get into standard normal distribution. If mean equal to 0 and sigma equal to 1, the curve would appear like this, right? If I let my average or mean be as is, and if I reduce the standard deviation from 1 to 0.5, the width reduces. Think about reducing your variation, reducing your dispersion. The width reduces, right? Think about a balloon. Say you have a balloon, right? What would happen if you put pressure from both sides? It would become thinner, but at the same time, it will have the peak, right? On similar lines, if you reduce the variation or the standard deviation here, your curve would reduce its width. Now, in comparison to the original curve, this one, if I let the average remain as is and if I increase the variation or standard deviation, what would happen? In comparison to the original curve, your curve would increase in width, and that is given using this dark green color curve. In comparison to the original curve, if you let your standard deviation remain as is, and if you move your average to the negative direction, your curve would move towards the left side, and that is given using this orange curve. Now in comparison to this original curve, if you let your standard deviation remain as is, and if you change your average to 1, it moves towards your positive direction. So the curve moves towards your positive direction. In this way, if you know mean mu and standard deviation sigma, you can characterize, you can come up with the shape of the curve. And look at this. If you want me to calculate mean for the random variable called work experience, right, and MBA dollars, sorry, my bad, I forgot that. It is 57.5, and if you calculate the standard deviation SD for work experience, I get 27.38. So when it comes to work experience, average is 57.50194. In standard deviation is 27.38682, right? Now let me do that for GMAT. So if I calculate the average of GMAT, which is MBA dollar GMAT, you get so much. And if you do a standard deviation for the same, that is GMAT, you get this. So for this GMAT random variable, average is 211.1643 and sigma equal to 29.33971. So for each and every random variable, you will have a different average, different mu, and different standard deviation sigma. Can I have some kind of a standard notation? My bad, not notation. Can I have some kind of a standard representation so that for each and every random variable, I have the same mean and the same standard deviation? Can I make this happen? Can I have mu equal to 0 and sigma equal to 1 for any random variable rather than having different values? What are the advantages if you can represent each and every random variable using standard mean and standard deviation? The advantage is that you can have some kind of standard mathematical tables which will help you do a bunch of analysis. I'm just speaking about standardizing things, that's it. Can we do this? Oh yes, we can do this. Why should we do that? I'll explain you all in just a moment. So in order to explain you all on why should we do that, I need to open a data set. I would this time open cars data set because we would be using this for our prediction purpose also. Yeah. So even before explaining this, I wish to explain you all about a simple formula called y is equal to f of x. Any output that you want to achieve depends on function of inputs. If you want to gain some good salary, then what are the inputs that you need to put in? Probably you need to go for a few certifications, enhance your educational background, enhance the knowledge that you have, put in some hard work, so on and so forth. On similar lines, any output that you want to achieve would depend on either one input or series of inputs, and X is called as input here. If you want to predict weight gained of a person, it depends on calories consumed. If I want to know the price of the used car, it depends on miles driven, year of manufacture, make of the car, so on and so forth. So any output that you want to achieve would depend on a function of inputs. Here also in this scenario, we want to predict the miles per gallon. MPG stands for miles per gallon. And the inputs that are provided to you are as follows: horsepower, and the units will be in bhp. You have volume, which will be in cubic capacity. You have top speed of the vehicle, which is the third input, which will be in some other units. Distance traveled given time. And you have the fourth input, which is weight. Weight will be in, say, pounds or kgs, whatever be it, or tons. Yeah. And when you want to predict miles per gallon, which is in a different unit altogether, miles per gallon, we cannot establish a relationship between all these different units and miles per gallon. You cannot have proper interaction between all these different units. How can you combine weight, cubic capacity, British horsepower, distance over time, miles per gallon? How can you combine all these things? It will become kind of a mixture, right? It will become kind of a mixture. And we do not want a mixture. Hence, it makes sense for us to standardize the units. Standardize all the units. What do I mean by standardizing? I mean making the data unitless. And how do you make the data unitless? There is a formula called Z is equal to X minus mu over sigma. Z is equal to X minus mu over sigma. This is the formula used to standardize the data. Remember another terminology here. Standardizing the data is also called as normalizing. Another name, right? You might be having pet names also, right? Other than your name. We have Srinivas. I can also call Srini. So there might be two different names. So standardizing, normalizing are two different names given to the same technique. Both of these techniques would make the data unitless. And what is the formula used to make the data unitless? Z is equal to X minus mu over sigma. So I'll explain this mathematically here. Let me choose top speed of the vehicle and weight. I'm just choosing a small set.